This do now is like a nice little overview of kind of all the topics on the test. So let's take a look. The first thing I'm going to look for in any sort of fraction before I take it to the power is it in simplest form? If I have negative exponents, I'm going to take those parts and move them. In this case, I notice that I have a's on the top and a's on the bottom. I have b's on the top and b's on the bottom. So I'm actually just going to write this out the long way. And just for my own, just to make myself less crazy, I'm going to write I'm just writing these with like a little space between them just so I can see them more easily. So on the top, I had 3. I had 1 A and 5 B's, right? This 5 only applies to the B. On the bottom, I have a 4. I have 3 A's and 2 B's. And then I'm just going to simplify. So 3 over 4 can't be simplified. Here I can take off 1 A. Here I can take off 2 B's. So then what I'm left with is on the top, I have 3 and 3 B's. And on the bottom, I have 4 and 2 A's. And now I'm going to think, okay, well, now I'm going to take that to the third power. So what would that be? Well, 3 times 3 times 3. And again, you can use a calculator here if you need to. Or you can use the top of your blue paper. If you find yourself often referencing the top of this blue paper, I would say, make sure to copy all of this onto your cheat sheet. This is b times b times b, right? There's 3 b's, and then there's 3 more b's and 3 more b's being multiplied. So that's b to the 9th. And then over here, it's 4 times 4, which is 16, times 4, which is 64. And then this is a times a times a times a times a times a. So that's 2 a's, 3 times, that's a total of 6 a's. And here's your answer. Okay, if you find that you're really struggling with that topic, like you would use topic F. Okay, I'm writing an equation for this table. So the first thing I'm going to do is just notice what the pattern is. I notice these numbers are getting smaller, so we're either subtracting or dividing. These numbers are getting smaller really fast, right? Like if I did 9 minus 6, that would be 3, but if I subtract 6, I'm not getting 1. So this must be division. Let's see, 9 divided by 3 is 3, and 3 divided by 3 is 1, and 27 divided by 3 is 9. So yep, I'm dividing by 3. So right away that tells me, okay, my equation is going to be exponential, right? Because I'm multiplying or dividing. So I'm going to grab this, and I can see that my number is getting smaller. Okay, so look, my y-intercept is going to go here in this position. And then my change is going to be, look, if I'm dividing by 3, that's the same as multiplying by 1/3, right? I'm using my cheat sheet here. Okay, so right here, my y-intercept, look, this is my x value is 0, so my y-intercept is 9. And then I'm multiplying by, look, I'm dividing by 3. That's the same as times 1/3. Times 1/3 is the same as dividing by 3, right? I'm multiplying by 1/3. So that is this to the power of x. Okay, and in terms of change, right, as soon as I saw it was division, this was exponential decay. Here, I'm looking to take all of this to the 1/4 power. Okay, a couple ways to look at this. So the first is to say, okay, well, like I'm going to take this number, I'm going to write it in radical form. So this is, the exponent is 1, and the index is 4. So this is the 4th root of 81. And I'm going to kind of just deal with the variables separate. So the 4th root of 81 means what number to the 4th power equals 81? And again, you could use your calculator here. If you could just put in your calculator 2 times 2 times 2 times 2, oh, you get 16. Okay, I need a bigger number. You can put in your calculator 3 times 3 times 3 times 3. Oh, that would be 81. So what number to the 4th power is 81? That number would be 3. And then here, I would just think to myself, well, in this situation, I always multiply exponents. So if I'm doing 12 times 1/4, what does that look like? That actually just looks like this. I end up doing 12 divided by 4. That's 3. So this would be x to the power of 3. And then I'm going to end up doing 40 times 1/4. That's going to be 40 divided by 4, which is 10. Okay. Another way to look at this, and you'll find a video on a different method on the website as well, is to think of this as, oh, this whole thing is to the 1/4 power. That means this whole thing is like, what's the 4th root of this whole thing? And the way that you could think about that is what, look, here's where the answer would go. What to the 4th power is this? And whatever to the 4th power is this, that would be your answer. So you can think, okay, well, like 3 to the 4th power is 81. Okay, what would I need 4 times to have 12 x's? Well, I would need 3 x's 4 times to get 12 x's. And then how many y's would I need 4 times to get 40? Well, I would need 10 y's 4 times. So that's just another way of just kind of thinking about it. Obviously the same answer, but just a thought as like a different way to kind of approach this problem. Okay. Here we're simplifying radicals. We can start, you can totally just like factor all the way down. I think for 200 though, what I notice right away is, oh, square root of 200 is the same as square root of 100 times square root of 2. So yeah, you could factor all the way down, right? But I think I would just see this as like, oh, this is like 10 root 2, right? Look, what I'm going to do is take like a half a shortcut. I'm going to say, okay, this is 100 times 2. 2 is prime. And look, I'm going to do 10 and 10. And look, rather than factor 5, 2, 5, 2, I'm just going to realize, oh, I have a double right here. I'm going to just stop at the double. So then when I go to factor this out, I have a 10, a 2, 1, 2, 3 n's, and 4 p's. And in terms of this number on the outside, the 5n squared, what I want to do is just, not forget it for right now. I'm just going to draw an arrow. I'll come back to it. Okay, I'm looking for doubles. So this is a double 10, single 2, double n, single n, double p. So remember that each of these doubles, like think about what this means. This means 10 times 10 is 100, but then the square root of 100, this just becomes a 10. So this double n, the same thing happens, right? Whatever number this is, I'm going to square it and square root it, and this just becomes an n. And the same thing happens with these 2 sets of p's. So this becomes a p and another p. And then my singles are what don't simplify, right? This is where I'm like, okay, well, these guys just kind of hang out at the end, and they can't simplify. We can't take the square root. We can't come out of the square root sign. And so just I have one more step, which is just to multiply this 5n squared on the outside. 5 times 10 is 50. This is n times n times n. That's n to the 3rd. And then I have these 2 p's, and then still this square root of 2n. And this is a situation where you really just have to be neat, because you can see there's a lot of pieces. So just, make sure you don't lose track. This is a new question type and not really a new topic. So let's take a look, and we're just going to place each of the following points on the number line, and we're just going to do it piece by piece. So let's look here. I have -7 to the 0 power. Okay, I know anything to the 0 power is 1. Anything to the 0 power is 1. And then this has a negative tack to the front, so this is -1. So I'm going to go on my number line. I'm going to go to -1. This is point A. B says square root of 36. Oh, well, square root of 36 is just 6. So I'm going to go, and I'm going to place point B here. Okay, this says 4 to the -1st. So remember, anything to the negative power says, oh, I'm on the wrong side of this fraction. I don't like this. This 4 wants to be down here on the bottom part of this fraction. And then there's nothing left on top, so we just have a placeholder of 1. So 4 to the -1 is 1/4. So where's 1/4? So let's see. Here's 0, right? 1/4 is between 0 and 1. This is like I have a quarter of a cookie. So I don't even have one whole cookie. I don't even have a half of a cookie. I have a quarter of a cookie. So this point right here is C. Look, this is 1/4, right? This is 2/4, which is 1/2. This is 3/4 right here. So that's 1/4 right there. And then 16 to the 1/2 power, I can think to myself, oh, this is, if I were to rewrite this in radical form, I would have 16, the exponent is 1, the index is 2. Those are both going to be invisible. This is just the square root of 16, which is the number 4. And that would be point D.